Researchers at the University of Cambridge have developed a groundbreaking solar-powered reactor that converts atmospheric carbon dioxide, CO2, into a valuable gas that could potentially power vehicles, supply energy to off-the-grid homes, and even be used in pharmaceutical production. The team's innovation, which takes inspiration from the natural process of photosynthesis, marks a significant advancement in carbon capture technology by addressing one of its most pressing limitations: the dependency on fossil fuels to power the carbon capture process itself. This new reactor is entirely solar-powered, which eliminates the need for traditional power sources, such as burning fossil fuels or storing CO2 underground, both of which pose environmental challenges. According to Sayan Kar, a chemist at Cambridge and lead author of the study, the technology represents a sustainable approach to tackling the global carbon emissions crisis. What if instead of pumping the carbon dioxide underground, we made something useful from it? Carr asked, noting that while CO2 is a harmful greenhouse gas, it can be transformed into useful chemicals without contributing to global warming. The solar reactor works by absorbing CO2 from the atmosphere during the night, much like a sponge soaking up water. When daylight arrives, the reactor uses sunlight to heat the captured CO2, initiating a chemical reaction that converts it into syngas, a mixture of carbon monoxide and hydrogen. This syngas is an essential ingredient in the production of a wide range of fuels and chemicals, including those used to power vehicles. The research team is exploring ways to convert the solar-generated syngas into liquid fuels that could power planes, cars, and other forms of transportation. This solar-powered reactor is part of a broader vision to tackle the dual challenges of atmospheric CO2 buildup and the reliance on fossil fuels for energy production. By using the reactor, CO2 can be removed from the air and repurposed into a clean alternative to fossil fuels, which is particularly important for sectors like transportation and chemical manufacturing. As Erwin Reisner, a chemist at Cambridge and the study's leader, emphasized, this system could significantly reduce the carbon footprint of industries that have traditionally been heavily reliant on fossil fuel extraction. Instead of continuing to dig up and burn fossil fuels to produce the products we have come to rely on, we can get all the CO2 we need directly from the air and reuse it, Reisner explained. One of the most promising aspects of this technology is its potential scalability. The team believes that these reactors could be deployed in remote locations, providing localized energy for off-the-grid areas, where traditional energy infrastructure may be lacking. This means that the technology could not only help address global environmental concerns, but also provide a practical solution for sustainable energy in isolated communities. The researchers' work lays the groundwork for a potential shift toward a circular, sustainable economy, where the CO2 generated by human activity is captured and converted into valuable resources, reducing the need for continued fossil fuel extraction. However, the success of this vision depends on widespread support for the political and economic will necessary to implement these technologies on a global scale. With further development and scaling, solar-powered CO2 conversion could play a crucial role in reducing atmospheric CO2 levels while helping to secure a clean and sustainable energy future.